Hello everybody, this is our video solution to problem 16 from our Fall 2020 Math 210 final exam. This is actually a two-part problem, both having to do with Taylor and or Maclaurin series. And they're very different problems, okay? One of them has nothing to do with the other. So let's handle this first one first. So we're asked to use a Taylor series to compute a limit. How interesting. That's not normally how we presented Taylor series, is it? Well, let's see now. The first thing I notice here in this limit is I have an exponential and then a bunch just of powers of x. It says use Taylor series for this, so maybe I should write down the Taylor series, all right, or even a Maclaurin series, since somehow things are getting near zero for e to the negative x. So the Maclaurin series for e to the negative x, and remember this really just means Taylor series centered at zero. All right, so I want this for e to the negative x. Well, maybe I don't know e to the negative x. Maybe we should do e to the x first. So the Taylor series for e to the x is you're going to get a sum starting from 0, and then you have 1 over n factorial x to the n. So if I want it for negative x, e to the negative x, then I'm just going to replace my x with negative x. Okay, of course we know this, by the way, this, right? The radius of convergence is infinity here, right? Like this converges for all x. So I get 1 over n factorial negative x to the n. All right, I rewrite this as per usual to pull out this alternator. All right, so this negative inside, that'll come out as an alternator, and then we still have over n factorial x to the n. And let me start writing this out. So when n is equal to 0, I get a positive over 0 factorial. Of course, you remember 0 factorial is defined to be 1. X to the 0, which is 1. All right, that's my n equals 0 term. What about when n equals 1? Well, now I'm going to get a minus over 1 factorial, so just a minus, x to the 1. Okay, so this is my n equals 1 term. Okay, how about we go out to the n equals 2 term? So when n equals 2, I'm now going to get a positive again over 2 factorial, so 1 over 2, x to the 2. All right, and this is my n equals 2 term, and this is going to keep going. All right, in fact, this next one will be a minus, right? It'll be minus, plus, etc. But I'm going to stop here because I note I have minus 1 plus x minus 1 half x squared. These just cancel out what I had. So what's happening is I'm taking e to the negative x, and then I'm basically getting rid of the first 3 terms here of the Taylor series. Maybe I should write down at least one more term. All right, okay, what would the next one be? Minus 1 over 3 factorial, which is 6x cubed. Okay, and then the rest of the stuff, okay, that's going to basically look like x to the 4th, x to the 5th, and higher powers of x, right? So plus higher powers of x. Okay, so I think we're making some progress here, because now when I take the limit as x goes to 0 of e to the negative x minus 1 plus x minus a half x squared over x cubed, I can rewrite this as the limit as x goes to 0 of, okay, I take the power, or the Taylor series for e to the negative x. I'm going to get rid of these first 3 terms because they just cancel out. And I'm left with, okay, I have negative 1 over 6 x cubed plus higher powers of x over x cubed. Okay, which I can break up. Okay, this first bit is just going to be negative a 6x cubed over x cubed. And because x is going to 0 but not equal to 0, that's very important when we compute a limit, I can cancel the x's, and I'll have negative 1 over 6. Plus, Well, I have higher powers of x, and I'm going to divide, right? Higher meaning, right? So these are x to the fourth or higher. Okay, so I have the higher powers of x, higher than x to the fourth, and when I divide by x cubed, they're all going to go down by 3. But the smallest one I get will be this x to the fourth over x cubed, which is an x. Okay, so these are going to be, this is some multiple of x. Okay, so that's the worst that we possibly get. Okay, but as x goes to 0, this multiple of x times x, that's just going to go to 0, right? Each of the terms is just going to go to 0, right? Term by term. And so this piece goes to 0, and so the whole thing is just going to go to negative 1 over 6. How neat is that? Okay, so let's go to the second one. The second one, we're computing a third order Taylor polynomial for the square root of 1 plus x centered at 0. Oh, this is nice. We're not having to recenter anything. Okay, fine. So we want third order Taylor polynomial for root 1 plus x, and we're centered at 0. All right, so we need to start writing down this function, its derivatives, and then evaluating it at the center, which is 0. So it's probably going to be useful to rewrite this as 1 plus x to the 1/2 power. And I'm going to make a little chart. So if this is my, let's call this f of x. So here's going to be my derivatives. And then I'm also going to look at my derivatives evaluated at 0 for various values of k. So I'm going to start with 0, 1, 2, and then I stop at 3. Why do I stop at 3? Because it's the third order Taylor polynomial. So the first term, right, this is the kth, or the 0th derivative, means I just take the function itself. So this is 1 plus x to the 1/2 power. Okay, now I take a first derivative. So I get 1/2, 1 plus x to the negative 1/2 power. Now I take another derivative. Okay, negative 1/2 times 1/2, this will be negative 1/4. 1 plus x, drop 1 to the negative 3/2 power. One more derivative, so let's see. Negative negative is positive. 1/4 times 3/2 is going to be 3 over 8. 1 plus x to the negative 5/2 power. Now I evaluate at x equals 0. Well, this is really great because each of these is 1 plus 0 to some power. Okay, 1 to this power is going to be 1. And let's see, then we're going to multiply by some constant. So we're going to get a 1, we're going to get a 1/2, a negative 1/4, and a 3 over 8. Okay, so this tells us the kth derivative of the function at 0. Now, how does that build us our Taylor polynomial? So our third order Taylor polynomial is going to be, well, we start with f0 of 0, so that's going to be 1, over 0 factorial, x to the 0. Okay, of course, this is just going to be 1. Then we get 1/2 over 1 factorial, x to the 1, which is just 1/2 x. Then we get minus 1/4 over 2 factorial, x squared. So this is going to be minus, let's see, 1/4 over 2 is 1/8, x squared. And then we're going to get plus 3 over 8 over 3 factorial times x cubed. And that's going to be, well, let's see here. The 3 factorial comes up. We can cancel a 3. So 8 times 2 is 16. So 1 over 16 times x cubed. And so our third order Taylor polynomial will be 1 plus 1/2 x minus 1/8 x squared plus 1/16 x cubed. And there we go.